Hey guys, in this video the brilliant Mr. B is going to be taking you through cumulative frequency plots, how we can make them and how we can get data from them. Now there are 15 different examples here, worked through at 3 different levels, and you can use this video however you want to. You can go through it quickly if you're feeling confident, or you can go through it slowly and then go backwards and start again if you're not feeling too confident. If you want more questions to really practice this skill, then there are loads more waiting for you over on my website.
Look at cumulative frequency graphs, and I will start off by drawing a cumulative frequency graph that is wrong to show you 2 really common mistakes. So at first glance, what a student might do is have a look at the data that's given to them in a table, and the first thing says that if we are in between 40 and 56, then there's a frequency of 2. So you might think, well, in the middle of 40 and 56 is 48, and we'll have a height of 2, and we'll draw a little cross there. Then for the second one, we're in between 56 and 72. Now 64 is in between those 2 numbers, and we have a frequency of 9. The third one, in between 72 and 88, is 80, and we have a height of 10. In between 88 and 104 is 96, and we have a height of 5. And then in between 104 and 120 is 112, and we have a height of 2. And then the next step might be to think, all right, okay, let's join these up with a straight line. And what we have there is completely wrong. So what do we actually do? What are the 2 mistakes that have been made here? So the first thing is where we plot the points to plot the graph. And we don't plot at the midpoint, we plot at the end point. We're plotting a point at 56, at 72, 88, 104, and 120. Now, the reason for this is that we look at the first group, we're seeing that 2 people in between 40 and 56. But we don't know exactly where those 2 people are. So this is about resting heartbeats. So it might be that one person has a heartbeat of 40 and one of 56. It might be that both people have a heartbeat right in the middle and they're both at 48. Or they could be anywhere in between. So where do we plot? Well, the midpoint at 48 is the point right in the middle, and that's usually a common place to plot things like this. But for cumulative frequency, we're going to plot at 56 because we know, we are 100% sure that by the time we get to resting heartbeat of 56, that both of those people have been accounted for. So we're going to go to 56, and we're going to plot at 2. Will be in between 0 and 0. That's where our first point goes. Now, to the second point, we have the second mistake. Now, we're going to plot this at 72, but we're not going to plot it 9 high. Now, this is because cumulative frequency is a running total. So if our first group is 2, then our second group is 11. And what we're saying is, we're saying that in our first group, by 56, we know for sure we've passed 2 people. But by 72, we know for sure we've passed 11 people. The 2 people in the previous group, and then the 9 new people in this group. And then with a third group, we're saying that by the time we get to 88, we know that we have gone past 21 people. We've had 21 items of data. The 2 in the first group, the 11 in the second group, and now the 10 more in this third group. And so what we're doing is adding the numbers on each time. So then we add on 5 from the next group to get 26, and add on 2 for the next group to get 28. And so right at the end, we're saying, by a resting heartbeat of 120, we know for sure that we've included the data of every single person we're looking at, all 28. So when we're plotting these coordinates, at 72, we're going to plot 11. Now that's going to be in between 10 and 11. Then at 88, we're going to plot 21. And because it's a running total, what you're going to see is that the values keep going up and up and up. Next, we're going to plot at 104. We're going to plot 26, and finally at 120 we're going to plot 28. And now we've plotted all our points, we're going to come to the third mistake that students tend to make. So the first mistake was plotting at the midpoint. The second mistake was just plotting the frequency. We're plotting the cumulative frequency, that means add it up as you go. The third mistake is joining it all up with a straight line. Now what we're actually going to do is we're going to join this up with a curved line. Now this takes a bit of practice and it has to be done freehand. There isn't really another method to do this. And after you first go, if it's not quite curved, then what you can do is just rub it out and have another go. Nothing wrong with that. So there we've got our cumulative frequency curve. Another thing we can do is that we can plot an extra point at 0. What we're saying here is we know that at 40, we know for sure we've had 0 people, because 40 isn't actually a possible value you can input into this. And then we know there's nothing below 40 because the table doesn't go that far. and that means you can just join your curve up to the very start of the graph as well. So there we go, we have a cumulative frequency curve. First, start off by doing two things. First thing is be mindful you're plotting at the end point of each group. And the second thing is to write down your running total so you know where you're plotting. So of 8. So your first number is always the same as the first group, but then we're going to add on 10, we're going to add on 21, we're going to add on 15, and we're going to add on 9. And we should have 63 people total going into this second cumulative frequency curve. And sometimes the question will tell you how many people are in there. So you'll know, oh, it's 63. I've got up to 63 at the end of the cumulative frequency. I know that I've not made a mistake. So here we're looking at cumulative frequency against age. So let's start to plot. So at 28, we're going up to 8. And with the axes here, it's a little bit difficult to see where the 8 is. So in a case like this, plot it as closely as possible. At 36, we're plotting 18, just before 20. At 44, we are plotting 39, so just before 40. At 52, we're plotting 54. And at 60, we're plotting 63. Once you plot those points, remember that the bottom corner will also be a point. And that's just looking at the very first groups. The first group starts at 20, so we know there'll be 0 at 20. Now we can join it up with a curve. Try and just use the kind of curve of moving your wrist to plot this. And then you might have a curve of different orientation at the bottom here. Do it in pencil, and again, if you make a mistake, rub it out and have another go. Now moving on to a third cumulative frequency graph. This one is height against cumulative frequency. First thing is just be mindful we're plotting at the endpoints. So highlighting them just reminds you we're doing those. Then we need to write down the cumulative frequency, and exam papers normally will have this in a table, and normally there'll be a blank column for you to write this into. So 4, add on the 8, add on the 19, add on the 11, and add on the 3. And once you've done that, you can start to plot the points. So at 136, we're going to plot 4. At 152, we're going to plot 8. At 168, we're going to plot 31, just above 30. At 184, we're going to plot 42. And at 200, we're going to plot 45. We're also going to have 0 at 120, right at the start. And now we can plot our graph. Again, draw the best curve you can with a pencil, rubbing out and trying again if you make a mistake. Then after this curve, you come to a flat bit, and then it'll curve the opposite direction at the end. And again, there we have a cumulative frequency curve. Now, our next graph has the same axes as height against cumulative frequency, but with a different set of data this time. So this will be a different set of people we are plotting the heights of. So again, think about the endpoints, add up the cumulative frequency, start with the first group, and then add up all the groups as you go. So add on 5, add on 8, add on 16, add on 10, and add on 5. Now we can plot the curve. At 136, we're plotting 5, so that'll be just before 6. At 172, we're plotting 13, so just after 12. At 168, we are plotting 27, 29 even. We're going to plot 39 at 184, and we're going to plot 44 at 200. And again, once those are plotted, we can draw a curve at the top, usually going into some kind of straight line, and then curving the opposite way at the bottom, remembering to finish in the bottom corner. Again, at 120, we know we've had 0 people so far, so we can take it right to the corner. Now moving on to the fifth question. So again, following our steps, be mindful of the end point. This will be plotting. Calculate the cumulative frequency. Add on 5, 15, 22, 13, and 8. Then start to plot. So at 56, we're plotting 5. At 72, we're plotting 20. At 88, we're plotting 42. At 104, we're plotting 55. And at 120, we're plotting 63. Remember again, the bottom corner, and then join them up. Start drawing a curve, evening out to a straight line, and then curving in the other direction. The final thing to notice is that these are different to line graphs, and they're different to scatter diagrams. In a line graph, you would not plot cumulative frequency, you'll plot normal frequency like we did at the start, and you'll plot with a straight line, which is the first question I did when I did the intentional wrong answer to show you common mistakes. The other thing to avoid is a scatter diagram, and you're not drawing a single straight line through as a line of best fit. It's not a scatter diagram. For cumulative frequency, you have to plot the cumulative frequency, which is the running total as the numbers as you go through, and you have to plot a curve. Now, why are we plotting these curves? Well, we can get some statistics out of them. And the first thing is it's really easy to find the median using this method. Now, the way you find the median is firstly we have to identify how many people total we have. In the first graph, it's resting heartbeats. I will need to figure out how many people total. Now the total, all you do is you go right to the very, very end of your graph. And once you identify the very, very end, the highest point, move across and see what number you get to on the y-axis. And we get to 13. So the total number of people is 13. So how do we find the median? Well, the median is the middle point. So the median is going to be at half of 13. So we take 13, divide it by 2, and this gives us 6.5. So now we follow the same method we just used. We're going to draw a line across. We find 6.5 on the cumulative frequency. Now 7 is in between 6 and 8, so it's going to be in between 7 and 6. So here, use a ruler to draw a line all the way across. And then as soon as you hit that red line, turn the line you're drawing and go down. And then you have to identify the point that you reach. Now to me, that's in between 88 and 80. So that's going to be 84. So if the median is the 6.5th person, then the actual value of that is going to be 84 beats per minute. Now, there are more things to discover. So, for example, the upper quartile. So, if the median is right in the middle of the graph, we can say the median is 50% of the way up the graph. So, let's note that onto question 1. The median line that went across, gone through half of the people's data to get there. And the total line, that was at 100% of the data. So the upper quartile is in between those two, and it's at 75%. So how do we find it? So again, firstly, identify the total. So the total in question 2, find where the red line stops at its highest point, draw a line across, and this is going over to about 62. So 60 is the line in between 64 and 56, and this is in between 60 and 64, so it's about 62. Again, you will be allowed a little bit of leeway in this, so don't worry about getting it absolutely perfectly. So if the total is 62, the median is halfway at 50% of the values. Now, the easiest way to find the median is to divide by 2. But we could use multipliers, and we could say, well, if the total is 62, we're going to multiply it by 50% to get the median. And that'll get us 31. So if we want the upper quartile, we have to change this a little bit. So the upper quartile, or we could just write UQ, is going to be the total, 62, but it's going to be 75%. It's going to be 3/4 of the way up. Now you can find 3/4 of 62 if you're confident with your fractions, or you can multiply it by 0.75 if you're confident with your decimals and your multipliers. There's different ways of doing it. And this is going to give us the 46.5th person. And so we have to find them, and we have to find what value they have to get our estimate. So we're going to find 46.5. We're going to draw a line across. And it's very difficult to get exactly 46.5 of the axes, given how close the values are. So again, this is where to remind you, it is an estimate, and you don't have to be 100% accurate. You'll be allowed a range of answers, because it is difficult to get the exact values off these graphs. Once you hit the red line, start going down. And this looks to be a little bit above 88. So I think about 90 is probably going to be a good estimate. Let's look at the units, 90 watt. This is weights against cumulative frequency, so it'll be 90 kilograms. You can look at the graph, the line at the top, when I went for the total, 100% of the data has been looked at by the time you get to that. Whereas with the upper quartile, you've looked at 75% of the data. Now the next thing to look at is the lower quartile. This follows exactly the same method, but rather than being kind of the median of the median, where you kind of look at the median in between the median and the total, this could be the other direction. It's going to be about 25%, and it's going to be the kind of median in between the median and 0. So again, we have a look at our data, have a look at the highest point of the curve, and look at what value it has, and it has a value of 48. So the total number of people is 48. So to find the lower quartile, if the median is halfway, 50% of the way through, the upper quartile is 75% of the way through. The lower quartile is 25% of the way through. So we're going to multiply 48 by 0.25. Again, if you're good at your fractions, you could find half and halve it again. So you could divide by 2 and divide by 2. Or you could think, well, it's a quarter, we're divided by 4. This is going to get us to the 12th person. The 12th person is going to represent the lower quartile. So find them on the graph, draw a line across. When you hit the red line, draw a line down, and we're just after 64. So something like 65, 66 would be a good estimate. Look at the units against weights, so it's in kilograms. And again, so you can visualize this, if we've gone through 100% of the people by the time we get to the top of the curve, the position of the curve of the lower quartile is 25% of the way through the curve. Now, the next thing to look at is interquartile range. Now, that's a distance in between the two quartiles. The upper quartile take away the lower quartile. Now, it's going to be a very similar method to find it. So first we want the total. So get to the top of the curve, draw a line across, and it looks to me that we've got 50 people in this cumulative frequency graph. So for the upper quartile, we're going to times by 0.75, and that's going to give us 37.5. So the 37.5th person through that curve. The lower quartile is going to be 25% of the way through. So 50 times 0.25 is going to give us 12.5, the 12.5th person. So let's find the upper and lower quartiles. So lower quartile was at 12.5, get as close as you can. Draw a line across, draw a line down. It looks like we're a little bit above 44. Now this is going up by 4 each time. So next line across will be 48, so in between 44 and 48, so 146, and the height is in centimetres. The upper quartile, we find 37.5, draw a line across, draw a line down, and it looks to me that's exactly on 172 centimetres. Now, to find the interquartile range, what we need to do is take those two away from each other. So set up a column takeaway, column subtraction. I'm going to use the calculator first, so might as well use the calculator for this. So 172 take away 146 is going to give me 26. So the interquartile range is 26 centimetres. And what that means is the middle 50% of people, because below the lower quartile, you've got 25% we've not looked at. Above the upper quartile, we've got 25% we've not looked at. We're looking at the middle 50% of people. And the middle 50% of people, I'm just highlighting on the graph here. These are half the people represented on the graph. That 50% of the people has a range of 26 centimetres. So we're just saying how close together the kind of most average people are. And I've just written on the graph that is the IQR, which is a nice way of saying interquartile range. And that's a short thing that you'll see for this, IQR. Just like for upper and lower quartile, you see UQ and LQ. So now I'm looking at the final graph. So firstly, we figure out how many people are represented in the graph. So from the highest point, it's going to reach about 67. So the total is 67. So to find a quarter of that, of the lower quartile, you can divide it by 4, or you can multiply by 0.25, the same thing, and we're getting 16.75. So we're going to find 16.75, draw a line across, hit the curve, and draw a line down. And it looks like we're on 148 for the lower quartile. Now we need to find the upper quartile, so we go back to the 67, multiply it by 0.75, and that's going to give us 50.25. So we've got up to 50 and a little bit above 50. Draw a line across, then come down. And it looks like we're just above 172. So let's say 173. Again, a bit of uncertainty there, but you are allowed a little bit of leeway. So we do 173, take away 148. I'm getting 25. And look at the units, that'll be 25 centimetres. But the exam paper might say something like allow anything in between 23 and 27, just because of several different ways we've made estimates here. From estimating how the curve is kind of curved when you draw it freehand with your hand, to estimating the total number of people in the curve, and then making the estimates for where the upper and lower quartiles are. And again, that 25 just refers to distance I'm highlighting in green now, and that is where the middle 50% of people represented on the curve lie. Now, you might have noticed that it was kind of difficult to get the values out of the cumulative frequency curve, and we could calculate them, but kind of just looking at it and going, what's the upper quartile, is very difficult. So now we're going to have a look at something called a box plot, and a box plot is an easier way to kind of record all these values without writing a list. So a box plot requires 5 different values. The first value is the minimum point, and the minimum point is the kind of very, very lowest part of the graph. And for our first table, which is weight against cumulative frequency, the minimum point is at 40. So on our box plot, I'm just going to mark off 40. The next thing that's important is the maximum point. So this is how high this goes. Now you'll notice, look at the box plot, there's no y-axis on the box plot. So we're not interested in how high the frequency is here, the cumulative frequency. The only axis it has is the weight. Now the maximum point, if you have a look at the weights, is at 120. So I'm going to draw a line at 120. So far I've recorded the minimum point and the maximum point. So what's next? Well, next we'll look at the median, and we'll find the median the same way we found it in the medium questions. So first we need to know how many people total are in this graph. So look at your maximum point, we're going to draw a line across, and we're going to see what number it comes out at. And it's going to 15. So if the maximum point is at 15, then the median will be half of that. So half of 15 is 7.5. So we're going to find 7.5. We're going to draw a line across from it. I'm going to hit the red line, and I'm going to draw a line down. And it's just before 80, so that's going to be something like 79. So I'm going to draw a line at 79 on my box plot. Now, often exams are going to have it lined up like I've got it here with the graph above the box plot. And one thing you can do is, using a ruler, you can continue this line downwards, and then you should be able to see where 79 needs to go. Now we've got the median. We need two more, and it's going to be the upper and lower quartile. So the lower quartile is normally the easiest. It's half the size of the median, or it's a quarter of the total. So 15 divided by 4 is 3.75. So just under 4. I'm going to draw a line across. I'm going to draw a line down, and it's just before 68. It looks probably about 66. But again, you don't need to figure out what number it's at, because if it's set out like this, you use your ruler. You can continue the line down, and it should get you directly to where you need to be. And I'm going to draw a line there. The last one is the upper quartile. Now, one way to get it is to multiply the lower quartile by 3. So if it was 3.75 on the frequency side, times that by 3, we get an 11.25. Alternatively, you can take 15 and multiply it by 0.75, and I'll get you the same thing. So we're going to find 11, and just above it for 11.25, draw a line across, hit the curve, and draw a line down, and then look at what number we're up to. Now we're in between 88 and 92, so it looks like it's going to be about 90 here. Again, you just use your ruler and come down, and then you can draw your line. Now we don't yet have a box plot, and there's one last little detail you've got to do with the box plot. I'm going to join up these lines we have. Now, how high these lines are doesn't matter. So I've done these about 6 squares high, but again, there's no y-axis on box plots, so that doesn't matter. But what is important is how you join. So the lower quartile, the median, and the upper quartile are going to be joined up. And once you've done that, you then join it to the minimum value and the maximum value, just like I've done here. And this kind of pattern is what we call a box plot. Now, I've color coded it, so you see my minimum and maximum values in green. You can see my lower quartile, median, and upper quartile in blue. And you can see how I've joined it up in pink. But normally this will all be in one colour, and it'll be in your pencil colour. So there we have our box plot. Now, what's the point of a box plot? Well, you can read off those 5 values really easily, and you can also see a few other things. So, for example, you can see that the 25% of people, the 1/4 of people on the lower end, are contained on that line. You can see that another quarter of people, the quarter that have the heaviest weight, on that line. And then you can see that the middle half of people, the kind of average people, are in the centre area. And you can see the entire box in the middle is 50% of the people, half the people. Or you could break it up into 2 halves and say you've got the lower quarter of the average and the upper quarter of the average. And we'll talk more in the comparing averages video about the kind of positions of these and what it means when you're analysing your data. Now, moving on to question 2. And we're going to follow the same process. So the first thing to do, the easiest thing, is to identify the minimum and maximum values we can possibly have. So this is resting heartbeat in beats per minute. So if you think about it, if your beats per minute is 0, then you're dead. So that's not going to be an option. And the highest on here is 120. That's a maximum value. But you think if someone's got like a value of 1,000, yeah, it's not going to be able to cope with that. It's going to be very ill. It's got 1,000 beats per minute. And that's probably going to be fatal as well. So you can use a bit of logic here and think, does the maximum and minimum values actually make sense? So the lowest value here is a 40. So we can draw those onto the graph. A line at 40 and a line at 120. Now we need to find the upper quartile, lower quartile, and median. We need to know how many people are contained on the graph. So at 120, maximum value, we know what the maximum is in terms of beats per minute, but we need to know what it is in terms of cumulative frequency. And that looks to me like it's going to 29. We have 29 people total in this graph. So the median, we half 29, which is 14.5. And we're going to read off what the median is. So it's in between 80 and 44. That looks to me to be about 81, 82. So you can just draw that as it is, or you could continue line downwards and then you don't really need to tell the difference between 81 and 82 because it's just going to be where it comes down. It'll be a little bit more accurate. So 29 divided by 2 gave us a median. For the lower quartile, we need to divide by 4 to get a quarter of it, and that's at 7.25. So at 7, or a little bit above 7 for the 2.5, draw a line across, draw a line down, so it's on 72 or just after the 72. Use your ruler to bring this down and draw the line. And now for the upper quartile, so 7.25 is the lower quartile, 3/4 of the way up will be 3 times more than that, and that's at 21.75. So I'm finding 22 and going just under 22. Draw a line across, draw it down, and it looks like that's exactly on 92. But we can bring this down using a ruler, and our line's going to be exactly on 92. Now we've identified the 5 values that we need, join them up. The middle 50% of people represented by the larger box. And then what we call a whisker are the 2 lines going to either side to the largest value and the smallest possible value. Again, the kind of intention behind this is you can see where the middle people, the average people are there in the middle box. And then the 2 whiskers going to the minimum maximum values. They're kind of your outliers, people who don't quite fit in to the pattern. Moving on to question 3. So again, we need the minimum point, 120, and the maximum point, 200. So draw those on. Then we're going to need the median. So before we do the median, we need to know how many people we're dealing with. And looking across from the maximum value, it looks like we have 32 people in this graph. So halfway would be 16 people. So we go to 16 and we see what value that gives us. It seems like it's exactly 160. We'll draw the line at 160. Now we need the upper and lower quartiles. So for the lower quartile, divide by 4, 32 people total. So a quarter of the way through will be 8 people. Draw a line across, draw a line down. This is just after 148, so something like 149. Okay, if you're not sure, use your ruler and just bring it down to the box plot. If it is set up this way, if it's not, then you'll have to just plot it from scratch. And then for the upper quartile, if a quarter of the way through is 8 people, then 3/4 of the way through will be 8 times 3 will be 24. Draw a line across, draw a line down, and it looks like it's going through 170. And again, if we're not sure, just bring it down. Once you have your 5 values, join it all up, box in the center, and 2 whiskers going out to the lowest and the highest possible values. Moving on to question 4. The lowest value is at the bottom of the cumulative frequency curve, and the maximum value is at the top of the cumulative frequency curve, and they correspond to 80 years old, because it's about age, and 60 years old. Now, to find the rest, we need to figure out how many people we're looking at here. So if we draw a line across from our maximum value, it seems like we are looking at 31 people. So the median will be halfway through, so 31 divided by 2 is 15.5. Draw a line across, draw it down, and it looks like we're going through 38 years. So the average person in this set of data will be 38 years old. The youngest possible is 20 years old, and the oldest possible is 60 years old. So we might be looking at distribution of people in a workplace. Now we need to look at the lower quartile. So the total is 31. Divide by 4 for a quarter, and that gives us 7.75. That's just under 8. Line across, line down. If you're not sure what number we're getting to, looks like it's 31, but we can just bring this down. And then for the upper quartile, if a quarter of the way through was at 7.75 people, times it by 3, and we're getting 23.25. So again, just above 23. Draw a line across, hit the red line, and draw a line down. This looks like we get to about 47, but again, we're going to bring this down and plot it here. Now you've got your 5 values, a box in the middle, and 2 whiskers going to the maximum value and the minimum value. Now the final question. So again, look at the minimum and maximum values. So 40 with the minimum, 120 the maximum. So add those on to the box plot. Then we need to find the median. So we need to find how many people we're dealing with here. So first thing is to find out what 100% of the people would look like. And looking across, it looks like we have 64 people. So the total 64, the median will be at 32. Draw a line across, a line down when you hit the red line. And it looks like it's about 82. Bring it down, draw your line at around about 82. Now 64 was the maximum, so the lower quartile, we want 1/4. 64 divided by 4 is 16. And we are exactly on 68. And if 1/4 is at 16, times by 3 for 3/4, for 48, 3/4 being the upper quartile. Draw a line across and a line down and see what value we have. So that looks like 94. Going to be uncertain, bring it down and draw the line. Last step is join it all up. Box in the middle, the 2 whiskers to either side.
Ouch! This is why in some videos I have unexplained scratches.